Bar charts are a common tool for comparing data from two or more groups, but really you don't get that much data. You maybe get a mean, and if you add error bars, you get the standard deviation. Adding individual data points to bar charts can provide a lot of information to the viewer. How many data points were taken in this measurement? What's the spread in the data? What's the distribution in the data? You can add a lot of value just by including these data points without taking up too much real estate on your figure. In this video, we're going to talk about adding individual data points to bar charts using seaborn's swarmplot and stripplots functions. At the end of this video, we'll also talk about alternatives to bar plots and how these same functions still apply. To start, I've imported NumPy, seaborn, and pandas, and we're going to be doing our plotting using seaborn. I've also made some data that we can use. We have this endpoints variable that we can use to choose how many data points we have in each data set. And I've made three different groupings of data, x1, x2, and x3. x1 and 2 are taken from a normal distribution with different means and standard deviations. And x3 is actually taken from a bimodal distribution, so two different normal distributions combined together. And we put this all together in one data frame called xdata, and that's what we're going to plot. We can start out with a simple one-line plot, sns.barplot, and give it our data frame xdata. And if we run this, we already have our bar plot. And as I mentioned in the intro, we get the mean and the standard deviation for each of these data sets, but that doesn't really tell us too much about the data. We can make a few adjustments to the bar plot, some customizations. So for example, we can change what the error bar is plotting. Right now it's plotting the confidence intervals. We can change it to standard deviation by giving it this SD argument. And for my error bars, I like to have a little caps on the edges, so we can give it a cap size too. That's about the functionality we get from a bar plot. So one way to add more information to this is to plot a swarm plot on top of that. And we can do this with sns.swarmplot of xdata, and let's see what this looks like. Here are those individual data points, but they're the same color as our bars. So let's just clear that up by changing the color to black. And what I would like to do in this plot is use the color argument and say color equals black. We get this warning, unfortunately, that the gradient palette using color is deprecated. In this case, we're not using a gradient palette, but just to avoid this warning, you can use this palette equals dark : black. So that's what I'm going to do here. With these data points now imaged on our plots, we can learn a little bit more about these distributions just at a glance. We can identify points that might be outliers, and we can see in this green plot, for example, we can see a bimodal distribution, which is not at all obvious looking at just the bar with the error bar. Now let's increase the number of data points to see what our swarm plot looks like then. So let's change n equal to 100 and rerun this code. And so now you can see the power of the swarm plot and what's in its characteristic shapes. You can see that it doesn't allow individual data points to overlap with one another. So based on the width of those swarms, we can tell a little bit more about the distribution. So we can see a normally distributed set of data overlapping this blue x1 data. We can see that in the orange plot, the data is a little bit more spread out. And we can see this distinct bimodal distribution in the x3 data. Another way to do this instead of using a swarm plot is to use a strip plot. So we can keep the same arguments and run the strip plot and see what that looks like. Rather than completely preventing data points from overlapping with one another, the strip plot constrains the points into a narrow channel in the middle of the plot, and then you can tell based on the density of the points how many data points are in a particular section. So you can still see in the blue curve, for example, it looks like the data is still normally distributed. Now let's keep increasing the number of points and now set it to 500. And now you can see the points get a little messier. There's just this big mass of black blob right on top of each of these curves. It's hard to tell how many data points or what kind of distribution there is. So to counter that, we can change the opacity value of these data points using alpha and set this to a smaller value than 1. So first let's try 0.5, and that's not quite enough. Let's try 0.3. And so here now you can tell the individual data points where there's just one data point is this kind of gray circle, and as you get more and more data points stacked up on top of one another, it becomes a darker color. And so you can see that there's a smaller density of points around the edges for the orange data compared to the blue data in the center, and especially compared to the green data in each of those modes of the bimodal distribution. Let's go back to the swarm plot and see how the swarm plot handles 500 data points. Immediately we see there's a problem. There's all these warnings that we're not plotting all of the data. And if you look at the plots, you can see very clearly what's going on. The swarm plot is forcing these data points not to overlap, and there's just not enough horizontal space on top of each of these bars to plot all of the 500 data points. Let's fix that problem by changing the size of these points. Let's try size equals 0.2. Oh, that's way too small. Let's try size of 2. And now we can clearly see those distributions. In blue, we can get a nice normal distribution. Orange has a slightly wider normal distribution. And we see those two different distributions in the bimodal distribution for green. So based on what you've seen here, you can choose which one you like better. Do you like the strip plot version or the swarm plot version? One last thing I'll recommend about the swarm plot is that if you want to be able to clearly see the error bars, because right now it's a little tricky to see the error bars, we can give these values an alpha 2. And so if you set this to alpha equals 0.7, now it's very easy to see where the data points are, as well as the error bars in this plot. Now that we've gone through how to improve a bar plot by adding these individual data points, I'll ask you the question, do you really need a bar plot? Is that the best choice for your data set? And sometimes the bar plot is not the best choice. For example, the bar plot is artificially tied to this value of 0 because all these bars start with 0 and then move up to the mean. But maybe that doesn't make sense for your data. Instead of using a bar plot, you can also use a box plot with very similar code, and we can still combine the swarm plots or the strip plot along with that box plot. So I'm going to copy that code from above and just paste it down here and change bar plot to box plot. I'll get rid of these other arguments and run that code. And here we can see that same information plotted again, but in the box plot you get a little bit more details. You get these interquartile ranges, you can see some points that were denoted as outliers, and these plots aren't artificially tied to 0. We can also include a strip plot instead of a swarm plot on top of these box plots, and here's what that looks like too. So now it's up to you. Would you rather use a bar plot or a box plot to present your data? And do you like the look of the strip plot or the swarm plot if you want to include all of your individual data points on your plot? Hope you enjoyed this video. See you next time.